Okay, so again, we're going with radicals. This is distributive property. This is some term. I have to distribute it to both. Now, there's a couple ways we can do this. So I'm going to split this into two questions, okay? Just so we can see that there's more than one way to solve this. And the first way, what I'm going to do is I'm going to take these terms, and I'm going to multiply 9 root 5 times 2 root 15, and then I'm going to do 9 root 5 times negative 7 or 7 root 3 with a minus in between, whichever way you want to look at it. So think of it like this. This now becomes 9, because this says 9 times root 5. 9 times root 5
Isn't it supposed to be 2?
Times 2. It doesn't technically matter the order. It's called cumulative property. Times root 15. Subtract 9. I gotta see if I can squeeze this all in here. Move this over. 9 times root 5 times 7 times root 3. Okay? So we've kind of squeezed it all in. Now let's try to get like terms or something we can kind of put together. Well, the 9 and the 2 we can solve. We can put those together, right? We can multiply those. And I can also multiply the 9 and the 7. Okay, so let's make this a little easier. 9 times 2 is 18. And I'm going to drop the brackets. We're going to be left with root 5 times root 15. The other one, we have 9 times 7 is 63. And we're left with root 5 and root 3. Okay? Now, before I go on from here, I'm going to show you another way we could have done this. I could have actually multiplied the roots themselves. Okay, so this is our version 1, we'll call this. Version 1, and this will be version 2. Both are correct. Okay, so what I mean by that is we're actually going to multiply our terms together. 9 times 2, what is 9 times 2 going to give us?
18.
Okay, so that gives us 18. What is root 5 times root 15 going to give us? It'll give us a root.
So 75.
Good. Root 75. Okay. And then same thing. What's 9 times 7?
63.
Yeah. And then what's root 5 times root 3?
15.
Root 15, right?
I'm sorry.
So, no, that's fine. Don't worry. I'm just going to bring this down one step. So we kind of skipped a step in our head there instead of writing everything. So I know they're not similar quite yet. We have 18 root 5 root 15. Okay. And here we have 18 root 75 root 15. Actually, I'm going to bring this up because in the next step they are going to become similar. So either way, I wanted to solve that. It didn't matter. What I'm now going to do is I'm going to break my radicals up. I can break 75 and I can break 15 into two terms. What can I break 75 into? Do you know?
15 times 5.
15 times 5. What's another one that we can actually find the root of? Or here's another way of doing it. How about this? What can I break 15 into?
3 times 5.
Yeah, those are essentially the only other two terms besides 15 and 1. So, shoot. Let's do 5 and 3. Okay, so let's try to break 75.
25 and 3.
Ah, that's right. 75 can also be broken into root 25. Okay? And root 3. So let's say root 25 and root 3. Now we're getting something that's relatively similar. If you look, we have negative root 63, root 5, root 3 right here. And this one, the only difference is 18 root 5, root 15. This one's 18 root 25, root 3. I can break 15 up. What can I break 15 up into?
3 times 5.
That's right, 3 and 5. So we're going to break 15 now. So this now becomes 18 times root 5 times root 5 times root 3, right? Because that's what 15 broke into. And we keep the rest the same. 63, root 5, root 3. Now, we're very similar here. The only difference is this is root 25, and this is root 5 times root 5. Okay, I want to show you the difference here. We already know that. What's root 5 times root 5?
Root 20.
Root 25. So let's kind of skip a step. What's the square root of 25?
5.
5. So this becomes 18 times 5 times root 3. So essentially, really, root 5 times root 5 we know goes into that, which turns into this. So really, root 5 times root 5 is just 5. These terms cancel out. Anytime you are multiplying the square roots with the same base, The answer is essentially just going to be that base, which is 5 in this case. So we kind of can skip a step over here. We're going to get 18. Root 5 times root 5 is going to be just 5 root 3 minus 63 root 5 root 3. And I forgot to write that on this side. 63 root 5 root 3. Keep that line going. Okay, these are both the same answers we're getting. 18 times 5 is going to give us 90, yeah. Root 3 minus 63 root 5 root 3. We can't quite combine these. 18 times 5, we already know. We're just going to jump a step so we're at the same level here. 90 root 3, 63 root 5 root 3. So either way we solve this, one way looked a little faster than the other. I end up at the exact same thing. Technically, I can factor here. I'm not sure if they want you to do that. There's a root 3 in both of these, so we can divide everything by root 3 as a common factor. Okay? I don't know if you remember doing common factoring. So we have root 3 on the outside, and then we'd have just 90 minus 63 root 5. And I guess that would be as simple or simplistic as they'd like it. And of course, we could do the same thing on this side. So we get root 3, 90 minus 63 root 5. Okay, and that would be, I guess, the most simplistic version of this. Okay, but either version, whether we actually multiply the radicals together or we keep them separate and work through it, we end up at the exact same thing. Okay, so there's a couple tricks in there. We always want to keep radicals that are roughly the same, and anytime you multiply radicals with the same base, it just becomes that base, we know.